Okay, let's take a look at this structure. This is propanoic acid. So it's going to have a 3-carbon chain, so we'll just start it the same with a CH3. So here's the CH3, then it's going to be bonded to a CH2. And so what we'll do is we're just going to start the zigzag thing here going. And so if we have one going up, then we'll just make this one like this. Hydrogen, hydrogen. So this is not the greatest actually drawing here, but that's kind of what we have. And so the 2 carbons are pointed up like this, the 2 hydrogens are pointed down and twisted. Okay. Now this carbon is a little different here. Because this carbon has this. And so this is tetrahedral, that's tetrahedral, but what is this carbon? This carbon's EPG is going to be trigonal planar, and its MG is also going to be trigonal planar. And so this carbon we're going to draw a little differently. This carbon, let's see, trigonal planar looks something like this, where a double bond. Now, what we're going to do is we're going to put all 3 bonds in the plane. You know, it could twist, like for example, this could twist out and that could twist in, but we're not going to do that. We're just going to put it flat, so it resides on the page. And then we'll have this and this oxygen here. Now, if I look at this oxygen, what's the EPG on this oxygen? How many groups of electrons around this top oxygen here? 3. If there's 3 groups, this is going to be trigonal planar too, so that's going to dictate where I draw the lone pairs. I want to draw one lone pair at 120, roughly, and another lone pair at about 120. And so I got the 3 groups trying to get it as far apart as possible, which would be about 120 from each other. The lone pairs, because of Heisenberg, we don't pinpoint them, but you know, that's where we draw the cloud for that. Okay, now we go on to this oxygen. This oxygen is what? EPG. Tetrahedral. And so what we try to do is we try to draw bonds in the plane. So it's going to be 2 in the plane, and then 1 coming out. So what I'll do is I'll draw the bond to the hydrogen in the plane. And that means where are the lone pairs? Well, the lone pairs are not in the plane, but one lone pair is going to be wedged out, right? And so one lone pair is wedged out like this hydrogen. This is tetrahedral. And so how do I show a wedged out lone pair? Yeah, I'm just going to fill in the circle here. And so this is trying to show a wedging out. And then one lone pair is going to dash in, and so I'll just dot it. And so it's essentially, it's the same thing as this. One wedge coming out, one dash going in. Do you see that? This one up here is all on the plane because it's trigonal planar. This oxygen is trigonal planar, which means that all the balloons are flat on the page of the board. Does that make sense? And so this would be my wedge dash drawing for this. Okay, let's do this one. This is going to be ethylamine, it's called. And that's the Lewis structure there. And why don't you do the drawing for this one, for ethylamine?